Hello, everyone.
Hello.
Welcome back to another week, another extremely exciting stream. We've got two very special people joining us from Polymaker today, um, and we'll be talking about some really creative uses of materials, and we'll be talking about the Quinley for Ultimaker. So there's going to be a lot of really interesting discussion. I think we're going to have us talking about things from the automation side, and then we're going to have our guest from Polymaker talking about how 3D printing at scale works from the material side of things, and we're going to be exploring a whole bunch of materials as well with them. Um, yeah, been looking forward to this for a while.
Yeah, we're going to cover a few interesting topics like metal manufacturing, not just by 3D printing metal, but we're going to see different use cases for one of their cool materials, which is PolyCast, which we've been using to um, enable automated 3D printing. But we're going to also see how other people have been using that material. And we're also going to get into a few details on some of our automation solutions. So how we automated the Ultimaker S5, we're going to go into that for a little bit. And then we're also going to see what else is going on Polymaker's side. So we're going to look at some of their customers' use cases and um, some of their other developments that have been recently going on.
Yeah, they're going to have a few announcements as well. So that
Yeah,
a super exciting stream. It's going to be packed with all sorts of information. So I guess without further ado, I'll introduce our guests. We've got Cody McKenzie and Nicolas Tokotu, both from Polymaker. Let me just bring them up on stream here. Um, all right, here we go. Thanks so much for joining us, and for those of you watching who don't know these guys, Nicholas has been working at Polymaker for 6 years now, and he works for North American Web Sales. He's got a computer science background, and he also has a lot of technical knowledge about their product. So very interesting. I'm super excited for that discussion. And then we've also got Cody McKenzie. He's been working there for 2 years, and he is a sales engineer. He comes from a mechanical engineering background, so a bit of a different perspective. And yeah, I guess I'll let you guys introduce yourselves further and tell everyone a bit about the background of Polymaker and how you started there.
Sure. So I'm Nicholas. Like you said, I come from a computer science background. So first, thank you very much for having us in your stream. Um, I started after graduated. I started with a project of 3D printed pollution mask. After that, I designed toys, digital toys that could be 3D printing, and in both projects, Polymaker was supporting on the material side, and they were sharing their labs for me to test the toys, etc. And then as it went, I started working for Polymaker as a printing engineer, and then after a few years, I became a product manager, and recently I took over the management of our North America online sales. So that's a little bit of my background. Really exciting to talk about PolyCast, 3D printing, automation, and all the topic today.
cool. Thanks. Yeah. Cody, how about you introduce yourself too?
Yeah, so hey guys, I'm really excited about this opportunity. First off, but yeah, I'm Cody McKenzie. So I've been with Polymaker for about 2 years. So I'm a sales engineer, work business to business with our customers. Um, went to college a little bit later in life, but when I was in the Army, or the unit I was in, we had several 3D printers that were used to print spare parts for vehicles, weapons, stuff like that. So it was always very interesting to me, and didn't really get to work with them much when I was in the military, but it was cool to see them in use and to have access to them. I was finishing up my last semester of college. and I was starting to look for jobs, and I came across this great opportunity with Polymaker, and the rest is history, so they say. So I'm very excited to sit here and speak to you guys about Polymaker and what we've got going on now, and what we're going to move to in the future.
Yeah, it's gonna be. I'm wait. It's gonna be a very interesting discussion for sure. And I'd just like to remind anyone that's watching, if you want to ask questions to any of us or participate in the discussion, please make sure to sign in and use the YouTube chat. We'll be reading messages live and responding to questions live as well. So why don't you tell us a bit about um, the background of Polymaker itself and how you guys how you went into PolyCast and actually using 3D printing for metals manufacturing.
So I'll give you a little bit of a background on Polymaker, how it started, where it came from, and the process to sort of how we got to where it's at today. So Polymaker started in 2013. There were 4 college buddies. All of them had like different backgrounds and materials and plastics, and their mission was to develop very high quality 3D printing. Or 3D printing material. So they were coming up with these new technologies and ways to better material at its core. And so around 2014, they did their first Kickstarter campaign to get a little more funding, to get a little more traction in the industry. By 2015, they started a rebrand program or a rebranding process to the Polymaker you kind of see now with the Polymaker teal, all the nice colors, and then they expanded. So they went from China. They put another office in the Netherlands, and very quickly expanded to 18 different countries into Europe, all over Asia in that area. And then by 2017, you've got 3 offices worldwide. You had one in America, the Netherlands, and China. And in 2017, they won Material of the Year. And then so we've just kept expanding, kept growing, put new technology into materials, jam-free, warp-free, nanotechnology, just unbelievable technology. And that's where we're at now.
Very nice. Yeah, like we've used some of your materials and like especially some of the ones that you don't get too often. Very good results. Specifically, I think my favorite one is your polycarbonate, Polylite, I think it's called.
Yeah.
That stuff works really well with our automation and like prints really nicely too.
Yeah. Yeah,
that was actually one of the earlier, not the earliest filament that they came out with, but just transparent, good heat resistance, all around like one of the top favorites for sure.
So I guess the way we started, talking was actually we had contacted Polymaker about an initiative that we were doing with FRC robotics programs, which was the idea was to create, and still is to create a 3D printing hub that would be deployable on site for the competitions and using printers automated with Quinley and using high quality materials from Polymaker and basically sponsoring a little 3D printing hub live on site at these competitions so that as teams would have, break things on their robots, they would actually have a resource to repair and make last second design changes right on site. But what this conversation today is more about is actually the really kind of weird and I think you said unexpected use case that we found for PolyCast. So maybe we should explain to people what PolyCast filament is and how it's currently used in the metals industry, and then we can go into like how we found a really interesting use for it as well.
Yeah, let's do that. So both of these guys here are very well very knowledgeable about PolyCast. But why don't Nicolas, why don't you tell us a little bit about sort of what this material is, how it's used in industry?
Yes, yes, absolutely. So a little bit of background on how we came up with PolyCast. You know, like Cody say now, we have now more than 7-8 years of history developing materials, and it was always about solving solution. If you see any technologies that we have developed, it was always to solve problems that came from the market, whether it's our nano reinforcement technology to solve brittleness of PLA, whether it's our stabilized foaming to solve, you know, wood mimic filaments, etc., etc. And then came up the issue of the layers that 3D printing have when you print. How can we improve that the roughness, the rough surface of the print? And what we came up with is a solution that would avoid the solution at that time. I'm sure you know was the combination ABS acetone, right? You were printing with ABS and then you use an acetone bath in order to smooth your print. So we were trying to find that there must be a better solution. You know, ABS is not the easiest to print. We know that, and acetone is also not the best chemical to handle at home, and even in a professional environment. So we tried to solve this problem, and then we came up with our layer-free technology. The layer-free technology was related to finding a material that is easy to print, easy to process with the 3D printing technology, combined with a chemical that is easy to source and to handle. And that was the combination between our PolySmooth and the polisher. So now that we had this technology that allowed us to create a very smooth surface, we're starting to have people that came up with more and more application using this new technology. And one of them was casting. Casting, because the print will basically define, you know, how your final part will look like. So if the print is rough, then the final part will be rough. So they were using PolySmooth in sand casting. You know, you use your model and then you just you know, you put your sand, and then basically it will create your mold. And then so one issue we had is the ash that could really affect the mechanical properties of your final part, whether it's the mechanical properties and actually also affect the aesthetic of your final metal part. So we then further developed this formula into PolyCast. So PolyCast used the layer-free technology that came from our PolySmooth combined with the ash-free technology, which you can see on the screen now. We reduced the ash content from 0.5% down to 0.003, which is huge when it comes to investment metal investment casting.
So what kind of problems would come up if there was ash left over inside it?
Yeah, so there's two main ones. The first one is from an aesthetic perspective. This ash will create some gaps in your surface, and you will end up with you know, a very porous surface, very rough surface. And the second one is the mechanical properties. So this porous surface is actually also within the inside that will really weaken the print. So that's the main part. Actually, there's one of the video on YouTube that is exactly comparing regular PLA and then they found out actually after the casting exactly the same process. He was printing a benchy, which I think is funny. Whatever material we develop, people begin by a benchy. But the benchy came out very rough with regular PLA only because of the ash, and the PolyCast came out very smooth. So that would be why the ash-free technology is an important factor when developing a material for investment casting.
Mm-hmm. And so, just to give people a taste of the way we ended up using PolyCast, which is, it was definitely not its intended purpose, but I had been experimenting with um, metal filaments, like sinterable metal filaments, of which there are a couple of brands. There's the stuff we used was the 316L that BASF sells, but I know there are a couple other companies that sell this, and it's essentially a filament that by weight is like 80 or 90% metal powder, which you can print through a normal extrusion system on an FDM machine. In our case, we were testing it with, Ender, Prusa, and Ultimaker. But the problem with that material that a lot of people find is very difficult to get to adhere consistently. And we were interested in the idea of being able to produce these green metal parts. I'll just pull them up, actually, the photos on the left, on our Quinley automation system, because as you can think, like lost wax casting or the type of casting that you would do at extremely high volumes with something like PolyCast, you still have this process of investment casting. You still have this process of you have to print a part and then you lose that part in the casting process. Where we were kind of interested in shapes that don't really work with investment casting, things that are only 3D printable. So we were looking at this sinterable metal, and one of the solutions, or one of the big issues with this type of 3D printing, it's called usually called BMD 3D printing, bound metal deposition, are things like the adhesion, which I mentioned, but also support material. And something that drew me to PolyCast was the fact that it's got this ash-free technology, because the concept was if I could print some kind of helper that would get the metal to work with our automation out of this PolyCast stuff, when I sinter it, it will disappear in the oven. So there'd be pretty much no post-processing required on the sintered metal parts. And if you look at kind of what's out there right now in terms of sinterable metal parts, you either have to struggle with adhesion and use like adhesive agents or disposable surfaces, or you do have to print an interface, but then that interface, which is usually ceramic, gets really, really messy when you sinter it. And so with the ash-free properties of PolyCast, it basically all of your helpers just disappear when you heat them in the sintering process. So I started messing around with that idea. I thought it was really interesting. And so what I did was the raft, because the PolyCast works really well with the vapor automation. So the raft gets printed out of PolyCast, and then with a dual extrusion system like the Ultimaker, the metal filament gets printed right on top. And so it's got this really cool property that when you sinter it, the raft will disappear, and that can be extended to things like support material and like support interfaces as well. So whereas a lot of other technologies use ceramic, like bound ceramic, which generates this like really messy powder once it's sintered, this stuff will just, I don't know, sublimate or decompose in the sintering process, and you'll have nothing left, which is really cool. And then some of the feedback we got was like, oh, well, I don't want to, have rafts in my sintering oven, and it turns out by some, like, I guess weird coincidence, the PolyCast also works really well as helpers for this metal filament because it doesn't bind to the filament directly. So you can see, I'll just switch to the big cam. but you can see I have a part here with, like, this is how it comes off the printer printed on this PolyCast raft. And the PolyCast just peels right off. It doesn't bind to the metal part at all. So it makes post-processing really, really simple and really easy. So it was, when we started talking to you about that, I'm curious what your reaction was.
Well, so when I first talked to you guys, learned about your application, how you were using Polycast, I mean, it's so simple that you're like, man, there's got to be more people out there that use it. But for me, this was the first time I've heard people using Polycast in this way. For me, Polycast was used working business to business. Our customers use Polycast for investment casting. That's how they use it. And some customers may keep things, tight-lipped and kind of want to be quiet about how they use stuff. But this is the first time I've heard about people using Polycast this way. So it's always neat to see people be creative, because that's essentially what 3D printing is all about, is being creative and finding a solution to a problem, whether it be your problem or a huge problem worldwide. It's just finding a solution to a problem. And that's what you guys did.
Yeah, and Luis brings up a good point. Some people are using the term MMF and not MFF and not BMD, because there are all sorts of trademarks in this industry. But yeah, he clarifies that it's like a heavily filled polymer filament, and most of the stuff on the market out there requires a debinding step. So what if that's the case with your material, you can just pull the helpers off via like an automated post-processing system, or just by hand. It's very simple. But what's interesting is that the PolyCast helpers are, as far as I've been able to tell so far, are pretty material agnostic. So you could even consider using them in a system that doesn't use like metal filled filament, maybe something that uses a metal paste or something like that, which was really interesting to me, because that's how our automation is supposed to be, pretty system agnostic as well. So if we can recommend for people doing high volumes of these metal parts, we can recommend that they just use a PolyCast graft no matter what metal they're printing on it. It was a really fascinating application, to me at least.
And also maybe adding a small idea is, you were talking about automation, and one of the things that is hard with automation is all the support removal part, like all the things that break away. And the layer 3 technology means that PolyCast is dissolvable in IPA. So
right. Yeah.
Somehow, if the metal part, the material you're using is not affected by IPA, you can have some kind of, it just drop in an IPA bath or ultrasonic bath, and then it will just dissolve the support away. And that's the great thing about having new application from customers. You were asking about our reaction. Well, you tagged us on the last live stream, and then we came on the live stream, and then you were explaining this, and yeah, we were just blown away. We took screenshot, we shared with the whole team, and then we started talking about how the innovation that come from the customer. And now we could think about developing maybe a kind of PolyCast that dissolve faster, for example. But you're gonna start seeing, where our material come from. It come from an idea. It come from how to improve things, and then we get to a new material. For example, in this case, a new PolyCast.
Yeah, that's actually a really good point, because I believe it or not, I actually didn't know at the time that PolyCast was the same or similar to your PolySmooth, in that you could dissolve it. So that and there are, the nice thing about 3D printing is like parts of it are actually quite automated, not the actual part removal, which is what we specialize with, but post-processing is actually really highly automated. So it's pretty feasible that this setup would be compatible with an existing system already, like for bulk processing of parts, like very, very high volumes. But yeah, the fact that it's IPA dissolvable and it's perfect as a support material because when like there's enough um, like there's an it's actually one of the it's hard to explain. It's very nice as a support material in the sense that when you're printing, it'll stay really stuck to the metal. But something I've noticed is like when everything cools down, you can just peel it off, and it doesn't actually take, it's not actually bound to your metal print, so it's not going to take chunks of the print out like it would, if you're using PLA supports on a PLA print, unless you dial your settings in perfectly, um, there's going to be some disruption of the surface. Whereas for this, I had literally done tests where I ran the nozzle into the polycast raft, so it was, occupying the same space. And instead of having chunks of polycast in the metal or chunks of metal in the polycast, um, they would always have a really clean separation and would give me really nice, smooth bottom surfaces. So I thought that was really interesting because you don't see that uh, with support materials that often. Either they stick too well to one another, or they don't stick well enough, and then you have issues when you're actually printing. Whereas with this, it seems to be a really nice sweet spot between the two. So whether or not you're, automatically post-processing these metal parts, the polycast makes supports way easier. Like you don't have to use tools or anything to break the supports out. It's just a
And I
super
heard
clean.
I heard that the green part, the part before sintering,
Yeah.
is very weak. And is that correct? So it
Yeah.
means that you cannot really like force too much on the part, right? To remove support, for example.
Yeah, that's a great point. It's very brittle. So if you were, trying to pry supports off of it, well, usually what people do, and I don't know how it works for the metal filament, like I don't know the exact workflow for metal, um, like the BASF metal, but usually what happens is people will print the supports out of metal as well, and then have to will sinter everything and then break the supports off after sintering, and that's where you run into issues where like the supports will literally be fused to your part, and it's like metal to metal fusion. um, Whereas with this you can kind of support it up to a point, because I think the polycast decomposes at like 300, was it 350 degrees or something? um but anyway, it's like good enough to stay on the part like throughout most of the process, and then once the part is actually hot in the oven and starting to, um sinter, the supports kind of go away, and it's interesting because it doesn't leave any residue, but it also prevents, supports from fusing to one another.
Yeah, we actually have a comment here saying that Polycast was designed to have easy support breakaway. So it seems like our results have definitely reflected that.
Yeah,
Yeah, we have a lot of experience in that domain since we developed our poly support also quite early filaments where it's always a fine tune between your layer adhesion, between the surface interface binding between model and support. So we have done a lot of tests on that, and now any new filament that we release, we already have this experience on what if it's used as a self support, and all of this. So I'm glad that now you're using this idea on further, and you expanded the idea.
yeah, it's also nice to be able to print supports out of the polycast because it's way less expensive than the metal. Like it's an order of magnitude less expensive than the metal filament, which means it's you know you don't have to spend have like 40% of your part be metal filament that then gets sacrificed later.
Hmm. Good point. Yeah.
We got a question about the material, the metal material that we're printing. So that's actually a BASF material called Ultrafuse 316L. And it's a stainless steel infused polymer. So it's actually
I think it's polypropylene. I think
polypropylene.
I
Yeah,
think so.
it's
I'm
a
not
really
sure.
nice.
They don't say.
It's like semi-flexible and it's surprisingly strong. Like it's not brittle, but it's 90% um, metal, so stainless steel powder.
Yeah.
But when you feed it through the Bowden tube, you don't need to like be super careful that it'll snap. It's actually pretty they've done it in a nice way, so it prints.
It's easier to print than NinjaFlex.
Yeah,
Than the hardest NinjaFlex, like the 98 stuff. It's much easier. You can print it through a Bowden, which is, the Ultimaker is a dual extrusion setup with Bowden tubes.
yeah.
But we should there we have I know it's awesome. I love getting all the questions from chat. And actually Xiaofan is saying that PolyCast was designed to be a support breakaway because the final parts with it are sacrificial because they get replaced with metal. Or in this case, they are used, as a sacrificial support for metal FDM. So we should probably move on to this next section and talk about because we've been talking about like this the metal printing and the polycast, but I think it'd be interesting to get some insight on like how, because we both deal in the domain of high volume users and people using 3D printing for production. So I think it'd be interesting to get into a discussion about how production use cases drive material development on your side at Polymaker, and then we can also talk about how materials affect really high volume production on our side, running a print farm and also having customers who run tens of thousands of parts a month.
Yeah, we do have a good video demonstrating an industrial use case for this polycast material too. So we'll show that as well at some point during this section of the stream.
Yeah, so why don't you give us a bit of an overview of how how, like, what kind of industrial use cases either polycast or just Polymaker materials are used, and how that influences the design of the material, like what kind of feedback you have.
Yes. So maybe there's two parts. I would say there's industrial case for polycast, which we can talk about one particular case study, and then I have a few other on more high volume printing because they both require different design for the material. So the first one would be for the polycast. So what we worked with a pump company. So they were designing. I think you have a picture of that particular pump. Is that correct? It's called M pump.
What was it called?
M pump. On one of the slides have like two picture on the process before and
Oh yeah.
Oh,
and
on the
after
slideshow you
polycast.
sent.
Yeah, we've got that.
Yeah.
Yes.
I think you got to go back a couple slides.
Can you
Yeah.
give it a go?
And
then I'll steer.
Mateo's got it.
I'll steer. Sorry about that. Is it?
So
There's a process here.
yeah, more it was towards the end of the.
This one?
No, it was really too. But it's okay. It was basically a metal part that was screwed on another part of the pump. And this part has three main parts, metal part. And the problem is they couldn't machine this part because it was too complex. So what they had to do is to machine three different parts, and then they had to weld them together. So the problem they have was first it was very heavy because they couldn't go into too much complex geometry for that particular part. And second is they have to weld things together, which mechanically sometimes can weaken the part, and especially that it's a pump in very high pressure, so you cannot allow any leak. So what they tried to find is how we could come up with a way to manufacture this complex part in one metal part, and that's how they found out 3D printing on one side. Obviously, when you start looking for producing complex geometry, this particular keyword on Google, you will definitely end up on 3D printing. One of the great advantage of 3D printing. And then second is they were looking, how can we use 3D printing in metal investment casting? And that's how they found this PolyCast. So they were printing exactly what they wanted in PolyCast. So there's no limitation. They can even use dissolvable support for any cavities inside their pump, their design. And then they were using this into, yeah, exactly, that's the one. So you can see on the left, it's a very bulky design, right? Because it's very hard to CNC complex parts. Mm-hmm. And then you have three main parts: the top one, the cylinder one, and the one at the back. And then they went from this to a one-time part that is bolted on the actual motor. So that's one of the great case study that shows multiple advantage of PolyCast. PolyCast is very good for big investment casting. So if you're talking about big parts, producing this with let's say regular process, which would be maybe using injection molding to produce the wax part, or even the current rapid prototyping in investment casting, which is usually SLA. Mm-hmm. Oh, did I lose you there? I don't have...
No, it sounds good on our side.
Okay, great. So currently SLA is used a lot in rapid prototyping, but it's very hard to produce a big part out of SLA for multiple reasons. So that shows the advantage regarding using PolyCast. The other one was they are not producing an amount that would explain the investment to a mold in order to create all of this wax part. And the third one is, like we say, the complex geometry. In order to do this kind of parts, injection molding is hard/impossible. Mm-hmm. So that's one of the case study that shows a little bit the advantage of using PolyCast. And if we're talking about what we learned from it, PolyCast went through version 1, version 2, version 3, and we now have even another version. And what we learn is the importance of the coefficient of thermal expansion during the burnout process. If your material will expand too much, or will basically break your mold. So we had customer coming to us and feeding their feedback back to us on how to make PolyCast even better. So that's kind of the process on how we improve material, learn from our customer, and make a better material.
That's an awesome story, and I really like I think this is where some of our application kind of overlaps, where it's for 3D printing in general is good for production of parts that are difficult to injection mold, but a lot of the time you have to justify the cost of 3D printing, because running a print lab in a company is generally very expensive. And so what we've found, and what our people running our system have found, is all of these really cool and unique parts that they've designed and prototyped that can only be 3D printed. They now have a path to scale it at a cost profile very, that's competitive with injection molding. So even especially for small parts, Steven did a research, or what is like a white paper,
Yep.
for a part that goes into, an HVAC system. It was for an HVAC magazine, and he found that with automated 3D printing, your crossover with injection molding is 300,000 parts per year, which is, pretty huge.
You wouldn't expect that much
Yeah.
from an automated 3D printer.
Yeah, you wouldn't think that the cost is that reduced. So it kind of it gets me thinking about what kind of applications, in um, even just for investment casting, not printing the metal directly, but doing investment casting, doing these unique low run parts that have to be cast, that have to be solid metal, um, but are either too complicated for a mold, or are volumes that don't justify injection molding. And the nice thing about the automation is those volumes are now, 10 or 20,000 per year, easily beats out injection molding, um, even though it's kind of a volume that you wouldn't really expect with 3D printing.
Yeah, like someone doing investment casting at a fairly reasonable scale could actually, if they want to use PolyCast to do the mold positives, then they could use 3D automation to produce hundreds or thousands of those at a relatively cheap cost compared to like any other 3D printing method.
Yeah.
So it's pretty cool how our technologies can kind of blend together to make certain kinds of manufacturing runs possible now.
I have a question, for either of you about the investment casting process. But is a process, like after you print your part, is it designed for a specific part, like every, or because what I'm thinking is, could I have, a part that changes slightly with every single print? Like maybe it's got a different serial number, or like the angle position of something changes. Do I have to come up with a whole new um, investment process for that, or can I have many different things kind of going through the same workflow?
Yeah, that's a great question actually. One 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 features of PolyCast that we try to make sure is that it combined with the current process that Foundry are using. So the lost wax casting process that they are using. What we wanted to do is to inject 3D printing in one part of the process. The whole process after that is exactly the same. If not better, if they are using other technology for the rapid prototyping side. So you can have basically very quickly, you basically print your parts, and then in order to make the process more cost effective, you're putting the part all together in a wax tree, and then you're starting the process, dipping in the different slurry in order to create the shell, etc. I think you have a slide with the actual process. So when you're looking at this process, you realize that you can have completely different part on the tree, and it won't really matter on the process itself.
Yeah, I'm just pulling up the image of the process.
Yeah, exactly. So you have this one. So 3D printing. So let's say we start the process with in mind the fact that you are going to print completely different part every time. So 3D printing, no problem. You can have an automatic system that just have a queue of G code, and then that will just print any part that you put on the queue. Oh, I just realized, is that why the name is 3DQ?
Yeah.
Is that because of the Q?
Yeah. Very creative.
Great. Very smart, very smart. So 3D print, and then the polishing process is the same. Mm-hmm. Whatever the shape of the part, it will be the same. Then you build your tree. Same, you can put different part on the tree, and then rinsing, burnout, ceramic dipping, metal casting, cleanup, and the precision CNC. So maybe the only part that may be affected is the precision CNC, because if you keep putting different part, then maybe you will have to change the
Yeah.
way the CNC will clean your part. But I guess, if you know exactly the order at which the part will come, then you can also kind of have a queue of G code for your CNC. So at the end of the day, you just unlock with your automation system, you just unlock a way to mass produce customized part, which is, I think, which is wonderful.
Yeah, I mean that was the first thing that got me thinking when I heard that you were already doing investment casting for production. Like imagine, yeah, there's a lot of like lower volume, lower end jobs that could now actually be worthwhile to do. Um, you know, yeah, at lower volume. So that's interesting. I mean, not that low. Like we are now talking about 10,000 parts a year being low volume, which it is for manufacturing, but it's absolutely not for 3D printing. Yeah, I guess. Um, so that was a super interesting use case. And Cody, do you I know there was another one that you guys were going to talk about of the use of your materials in for actual production of final parts.
Yeah, so well, that's the thing. That's the beauty of, excuse me. That's the beauty of 3D printing is the wide range of uses for it. So in one of those, we have several large-scale production customers that use these, and most of them, not most of them, but a couple of them are using them for prosthetics, and not in the prosthetics of someone losing a limb, not that serious, but maybe it's a cast. Maybe someone's broken their arm, a cast like that. We have several customers that are using them for pediatrics. So babies, when they're born, some of them have what they call like a flat head syndrome, where they lay on their head so much they start developing flat. The back of their head starts becoming flat. So they'll print helmets. And and as you can see, like not every child or baby is going to have the same size cranium. So they're able to customize that helmet to fit those children in special cases. And then, of course, automotives, that's a huge one. Using our material and printing electrical housings, mostly behind the dash sort of parts. It's been endless, but those are the main parts for us.
Yeah, those are two interesting use cases. So custom fitted parts to like humans, and we're all different. So
right,
3D printing does make sense for that specifically, in terms of prosthetics or otherwise. It's really cool to see 3D printing being used like that.
Yeah, so especially like with the castings for broken arms, ankles, something like that. It's a simple 3D scan. It's uploaded. You can quickly print it off, and a customer's got or a patient's got a cast on their arm. That's low profile. You're not carrying around this bulky, cast for months. You've got something you can easily fit under. Fit on your arm, but that'll fit under any kind of clothing. Growing up as a kid, I've broke every arm, every ankle just about. So I know what it's like to wear cast, having to take a shower with a cast, or having to roll your jacket. It's cold outside, and you've got to roll your jacket up to fit your cast. Well, now we're able to make these low profile castings, so that's really helped out a bunch.
Yeah, they look pretty cool too. I've seen some of them have either different designs or different colors. So, if it's a kid getting a cast, then they can actually show it off instead of having to be embarrassed about it, which is pretty cool.
And I think that's also important, like with Polymaker, and I think that's what a lot of people love about Polymaker is all the colors that we offer for most of our materials. You can easily go through our website and look at any material. Obviously there's the few that don't have multiple color options, but looking at our PLA, PETGs, any of that stuff, you've got a wide range of colors, and And it doesn't just have to be for kids and toys and castings. We have several customers that are using our colors for packaging materials, or their packaging for their own end parts.
Yeah, actually, we do print some packaging materials too, so we might have to talk to you about that later.
Absolutely. Yeah, that's great.
Um, and just before we, because I think this is a really good discussion that kind of bookends what we're gonna show for the Ultimaker in a second here. But before we go to that, Michael is asking if PolyCast can be used in an adaptive slicer. So I'm not sure what specifically he means by adaptive slicer. If it means like, you know, where you have like adaptive parameters, or
I'm not too sure what an adaptive slicer actually is.
um,
Yeah, give us an answer in chat and we'll
yeah,
try to get back to you.
if you clarify, I'm sure it's something interesting. It might mean like the
Non-planar?
non-planar.
I mean,
Maybe.
it's just a material, so I'm sure it can be.
Yeah. I don't know. I'd be curious to know more about what you mean by that, Michael.
Also, yeah, you're asking how to get in contact with 3DQ. We have our website in the description. It's just 3dq.com.
Yeah.
And you're also in contact with us right now.
Yeah, you
So,
can ask questions in chat live.
yeah.
Um, so we're talking about, okay, the use of 3D printing in manufacturing from a material side, and how Polymaker has done a lot of work to make sure that the materials, suit actual like manufacturing and production needs. Um, and something we've been wanting to show for a while now is actually um, the Ultimaker assembly, which is what we intend to be more of a robust, um, you know, industrial setting type system for the print for Quinley. Um, Not to say you can't use Prusa's renders, but when you get an Ultimaker, you have dual extrusion out of the box. You have really good support, really good tutorials, a really good machine that will last years. So you kind of want this perfect combination of good materials and a good machine, and then of course actually like the dual extrusion is what makes stuff like this kind of metal experimentation possible.
Mhm.
So do you maybe want to take over and talk about the Ultimaker? We have
Yeah.
an actual demo of how easy it is to install into the Ultimaker that we'll play on screen here.
Yeah. So we were looking at getting Quinley automation onto a more industrial 3D printer. So people get Ultimakers because they want something that works. They want to make good looking parts that they don't have to fiddle with the printer to get things out. And also it has the dual extrusion capability. So we were thinking Ultimaker would have a really good potential for things like using dissolvable supports to print really complex models and automate them. But then we also notice a few different possibilities for dual extrusion in particular. And so the metal 3D printing was one of them. So we designed this automation system for the Ultimaker with a couple things in mind. So we wanted to keep the we wanted it to have less interference with the Ultimaker system. So essentially it would be like a drop-in thing that works with everything that Ultimaker's already designed. And doesn't really work around anything else. So
it's kind of an interesting. It's a similar philosophy to how you designed PolyCast to kind of get injected into the existing process. In the
yeah,
same way, we want Quinley for Ultimaker and for all printers really to it's keep the operation of the machine the same, because if as soon as you change that, it would introduce a really steep learning curve, which is expensive and makes industry adoption hard. But I'll play the video, and I guess you can talk over it, Steven. But
yeah,
we made a very, separate and easy to install.
yeah. So the Ultimaker itself is super easy to set up. So we tried to make this automation upgrade as easy to set up as possible. So you're going to be watching me doing this 2-minute installation for the hardware, which is pretty cool. 2 minutes isn't too bad. I think
It's
most people
pretty
can handle
quick
it.
for a printer mod.
Yeah. So, um, yeah, there's like not a whole lot of room inside the Ultimaker, so you see a lot of these 3D printed mechanism components are specifically designed so that they don't interfere with any of the motion of the Ultimaker. So you can see the bed lowering down.
And it
Um,
just like narrowly evades all of these moving parts.
yeah. So that was about what, like 40 different components that went in about a minute.
Yeah, in about a minute.
Then we just have these covers that we printed, and these go over the stepper motors just to hide them. Looks pretty easy.
Yeah, it's just designed to be completely drop in so that if someone wants to convert their Ultimaker over, it's not a huge commitment that they have to make. And the
Mhm.
other thing, which I think Luis will be, is happy that we've done is it doesn't, you know, destroy or modify any of the base function of the printer. So if you don't want to use it as an automated system, you can just use it as a regular printer, and none of
Mhm.
the mechanisms or the software is going to get in your way. And I guess it'd be interesting to hear from you guys your perspective when entering, industrial use cases. What are some of the biggest obstacles to adoption?
Adoption of automation.
Well,
Is that
in
correct?
your case, it would be materials, but an adoption of anything new into the workflow.
Yeah. Um, Usually there will be there will be two main obstacles, I would say. The first one is the process itself. We when we design a material, we usually take a three-step approach. The first one is uh, processability. So we have to learn about the 3D printer. So that's the biggest one where we need to inject the material in, right? Is what printer is going to be used, and then what are the printer capability, and then is the material processable in that printer. So that's the first one. We need to learn about how the material behave in that particular process. There is FDM, and then there is also large scale 3D printing where the principle is the same, but material are going to behave very differently. So that's one first obstacle is what printer are you going to use? And in your case is the same, right? Depending on what printer they are going to use, the hardware might be different, maybe the software as well. So that's the first one. The second one is functionability. So which means we have to find a material that would fit the actual application. If I have to give one example, would be the XCV car, the 3D printed car that we have done. The first one was we had to learn about the printer that they were using, and actually was a little bit easier for them because they designed their own printer, so we could learn about what exactly the printer was, how it was behaving and what it was capable of. The second one was to find materials that after being printed could perform to the level that they were looking for. And then yeah, exactly, this car. So it was exactly the three-step process, and then the final one is to integrate this into an actual solution. We were talking about the printer, we were talking about the material that fits the functionality, and we need to integrate this into a solution to be applicable. Talking about software, talking about if the solution has to be producing this part, then we need to start also thinking about the automation if they want to print this to automate the printing and manufacture this car. So that would be a summary of the three-step approach to developing material, and that each of them brings different obstacle.
And then I'd be interested to hear from your perspective, Cody, as a sales engineer, when you're approaching companies about using, new materials or working with them to develop new materials. How does that conversation usually go in terms of pulling 3D printing and actually kind of diving and committing to that kind of process in their production?
Yeah, I think Nicholas hit it really well. I think that three-step process is great, but I also think it's making sure the customer understands. Obviously, the customer has their need, what part they want, but it's making sure the customer understands the material, how the material is going to react in their application. Making sure it's not an over-engineered material, making sure it's not an under-engineered material. Making sure that I understand their process. So if a customer comes to me and says, hey, I have this application. First thing, I'm going to talk to them about is like Nicholas said, hey, what kind of printers are you using? What type of material are you looking at using? What kind of stresses are you going to be putting these parts under? And then when you learn more about their application, their printers, what they're using, what materials you have in mind, and then you can go from there and kind of see, hey, is this customer going to need some sort of nylon? Is he going to need some sort of blend material, or can he get by with a tough PLA, a PLA plus, or a standard PLA? But Nicholas hit the nail on the head with that. All I got to say is just a big thing is making sure the customer understands their needs and making sure that they're not getting too much material or too strong of material or not a strong enough material.
Yeah, well, I know 3D printing is new to some people, so they've heard of it and maybe done a little bit of it themselves, but actually using it for like real use cases, then I guess it really makes a difference. When you have your materials
we just got back from Rapid TCT in Chicago about a month ago, and you saw that a lot. We have customers come to our booth and they're saying, hey, this is my company. I'm here, I'm looking at printers and I'm looking at material. Here's my application. What do I need to do? So, I would talk to them, say, hey, what kind of printers are you guys looking at? What's your application? And then I would give my suggestion, and then we would go from there.
Yeah, it is. It's interesting. Like we've found that nowadays people who are newer to 3D printing seem to adopt it very quickly. Like I don't know if we've had enough examples to say that this is a pattern, but something I've noticed is people who are just getting into 3D printing, they maybe been doing it for 2 or 3 years, and they actually do it for like production purposes, tend to scale up and commit to the process very, very quickly. Back last year, we were doing a whole bunch of interviews with, small business, like Etsy store type businesses. And what was really fascinating about them was almost all of them had just started 3D printing in the last 2 years, 18 months, and they had already scaled to between 10 and 20 machines. I just thought that was interesting, like just how fast the adoption curve is. And then what was extra interesting to us is you would almost never find anyone that has more than 15 or so machines, because they would hit like a hard labor limit, which is kind of where the automation and where Quinley comes in is to solve that problem. But I don't know, is that something that you started noticing more recently, just how like newer people or people who are just now ready to get into 3D printing seem to be much faster at adopting it?
For me personally, yeah, I agree. I definitely agree with you. I think people that are new to it are more like a sponge, and they kind of just want to take everything in that they can. They'll take in any kind of knowledge, any kind of advice you can give them. And I think people that sometimes get stuck in their ways and get comfortable with their, we've got our 10 printers. This is what they do. This is the material we use. These are the applications that we've got. They can sort of get comfortable and not want to branch out and try something new, try new materials, what have you. So I definitely agree with that.
I think if you're starting 3D printing, then it's a lot easier than if you were doing something else and you have to switch over.
Hmm.
So if you're already doing all your parts, I don't know, if you were like sculpting them out of clay instead of printing them, for example, you wouldn't want to change the way that you've been doing things. But
Yeah,
if you have an
people.
idea, then it makes sense to 3D print it. Then it
Yeah,
becomes comfortable to scale up using more 3D printers.
yeah, yeah, and I definitely think people get comfortable in their ways and tend to move away from pressure instead of moving into it. And trying something new is obviously going to put pressure on somebody to learn something new. So obviously they're like, I don't know this, so let me continue my my old way of manufacturing this part instead of looking at something that's going to help them, that's going to have lower overhead, lower cost. Um, so
Yeah, I think, and I think like those people who don't recognize the significance of 3D printing are going to be at a significant disadvantage as the technology gets better, as
right,
you know the material science gets better, as um, solutions come out to help scale it better and help produce at a lower cost. All of
yeah,
these new guys are going to come in, they're going to absorb all of this technology, start using it, and I think they'll outpace a lot of
right.
their competitors.
Yeah, and in my opinion, we're still in the stone age of 3D printing. That's just my opinion. I think we're still, like I said, just early on in 3D printing, and I think 3D printers evolve with materials, and I think materials evolve with 3D printers. I think as printers get better, materials going to get better. As materials get better, printers are going to get better.
Yeah,
Um, so
yeah, I definitely agree. I think something interesting that we are constantly learning. Both Steven and I come from a hobbyist background,
mhm.
and as we've transitioned to using 3D printers for production, it's completely changed how we have to think about 3D printing, how we have to treat the technology, how we have to design our workflows. It's completely different than when you're running it as a hobbyist. And unfortunately, I think something that's impeding a lot of the progress in the industry is a lot of people do have this like prototyping hobbyist mindset. And
Mhm.
it was funny actually at Rapid, when we first showed off the automation, this was 2 years ago. um, a lot of people who had been in the industry for 10 or 15 years came up to it, and we talked to them about it, and then they just wouldn't understand like what was happening, or why anyone would want to use 3D printers at high volume. And I found that really fascinating, that there seems to be a really kind of entrenched mindset. And it was something that personally I've had to, break, going from hobbyist to production. But um, and actually, on top of that, just talking with all of these print farms, um, it's really interesting to learn how they almost everyone I talk to has these extreme, like the same problems and the same sort of sequence of solutions to each of those problems as they start transitioning from 3D printing for prototyping to 3D printing for production. And I mean, it informs a lot of our software and hardware development, but it's just so weird to see like everyone is kind of making the same mistakes right now in that transition. um and I mean, that's why we take that and we try to put it in our software to make sure
Mhm.
to help people avoid that. But it is interesting. And it's interesting to hear that you've sort of seen the same thing. um Maybe Nicholas, if like from your end, since you've been in this industry 6 years now, um professionally, I'd be interested to hear your take on that.
Mm-hmm, mm-hmm. Well, first, I agree with Cody about having material and printer manufacturers working together to to develop the industry. And then we recently have, I mean, few years having the software coming in that now plays, big part into developing the tools itself. I do believe customers are driving, what we need to do. They are basically, taking the tools that we are making, and they are forcing us to grow the industry, in order to make the tools what they need. And I think that's why, one of the great thing about 3D printing, which I love, is the community. You were talking about being easier to get into 3D printing. I do believe that whether it's in the hobby side or even, there's still a big overlap between, hobbyists and the people that are using 3D printing professionally may have started in the as a hobbyist as well.
Yeah.
And I think this community is what is making the entry into 3D printing as easy as it is right now. I mean, on Facebook, we're talking about hundreds and thousand people in one single group. You're asking a question, and literally in a few minutes you have an answer. And I think which makes the learning curve much easier these days. And I think the more we are going to combine this, the more we are going to combine material cooperation with printer manufacturers, with software, with post-processing, the more we have all of this collaboration, and the more we are going to drive the industry towards. That's that would be my take on this.
Yeah, I think that's especially what you said at the beginning, about how customers are driving and forcing, innovation in the different, like in all of these products. I mean, something that I'm very proud of that we've done here is actually work with our customers to design new workflows and new features, not just like through feedback forms, but literally, we sat down with them, I think Tavi did 6 hours of interviews, getting just a list of use cases and formulating that into, a new workflow and into the new UI. And now we have over 20 people who are beta testing it for us, which I think is more than most people could ask for. And it's been really, it's like, let's just say, usually when a UI update comes out, not very many people like UI redesigns, but so far the feedback we've been getting on it has been like very positive in terms of how things are laid out and how it is to work with it. And I think you can only achieve that by working so closely with the customers.
Yes.
Yeah, I think it's nice talking about how 3D printing is still such an early technology. Like, it's nice to know that we're still in the beginning of it, and there's a lot that we can still do. So it's nice, like, I don't feel like I've missed the boat on 3D printing. I think people who are new to it feel the same way. It's nice to kind of get in on this stuff while it's still early and everyone's still excited about it.
Yeah, it's interesting too, because 3D printing is like, it's not new technology, but
it's not new.
This era has definitely been, like the last, few years has definitely been an insane amount of innovation. And I think what we're going to see in the next couple of years is, okay, we have really good technology now. How do we actually scale it for manufacturing, for production, for industry use? Because I think that's where our problem is now. And that's like, everyone is working on that kind of thing. How do we make materials better and consistent, more consistent for the use cases our customers require? How do we make printers work the way they need to? How do we make the operator more efficient at what they do? Like, where are those steps where we can either automate processes or develop products that are more efficient to use? And yeah, I think we're right at the beginning of that, and it's going to be a really interesting, it's going to be really interesting to see how it goes.
Yeah, well, that's a good transition into possibly some of Polymaker's next steps. Cody, do you think you could tell us a little bit about sort of what's coming next, what's coming soon for Polymaker?
Yeah, so we've got a lot of interesting stuff coming up, particularly our Polymaker 3.0. I think, I think, and this is generally speaking of everybody, I think it's everyone's goal is sustainability. I think preserving the one Earth that we have, or at least we know we have right now. Um, and I think it's really important for Polymaker and for 3D printing to really be at the forefront of this. And so we started this new program with the One Tree Initiative with our Polyterra PLA. And that was just the start of it. It was a new material that we came out with early this year. And so what we did was we found a more biocompatible PLA. We put it on a corrugated cardboard spool, cardboard box. We got rid of any unnecessary packaging, and we also paired with the One Tree Initiative. So with every one spool sold of Polyterra PLA, that goes to plant one tree where that spool is sold. And so that was such a big hit with our customers, not just the PLA, not just the printability of it, not the print consistency, none of that. It was the fact that we're doing our part to help preserve this earth that we have, to help make it a better place and leave it a better place. And that was such a big hit that we were going to start transitioning all of our filaments to cardboard reels, to cardboard boxes, to less packaging. As a sales engineer and being more customer facing, I was able to speak with a lot of customers, and their biggest complaint was, what do I do with all these reels? What do I do with all this plastic? And you just tell them recycle it the best you can. Well, now we have an answer to that problem, and that is corrugated reels, recyclable boxes. Yeah, anything you want to add to that, Nicholas, or anything that I missed?
No, I just well. It's we learn a lot in our therapy.
Nicholas, you're breaking up a little bit.
Sounds a little bit robotic.
It's right.
We'll give you maybe a minute just to see if your internet gets better. Can't really hear you too well.
Wait.
Is that better now?
It's still hard to hear.
Mm-hmm.
Basically, it was
Yeah.
Oh wait. I think
Yeah.
it's
So
fixed.
I think we got that.
Yeah,
that was I hit most of it. I know I spoke really fast. I get really excited. So feel free to ask me any questions. But yeah, so we just were able to learn a lot from our Polyterra PLA, how important it was not only to us but to our customers, that we're doing our part to help save the environment. So we only get one Earth that we know of. So
Yeah, that's pretty important. 3D printing sustainability is it's kind of new, but everyone starts to realize, like especially now, that it's actually something that worth caring about. And, we're seeing quite a few changes in the industry to reflect that sustainability, and cardboard spools are definitely the way to go. No reason to be having all these plastic chunks just lying around having to get
absolutely
trucked out, because they really don't like recycling them, especially over here. We don't have a good way of doing that.
I have one printer at my house, and I know how. Even for me, I don't print near as much as a lot of people, and I'm like, man, what am I going to do with all these plastic reels? And I'm a big guy on the environment, and doing your part. If each person does their part, and you make your place a better place, then the world's going to end up being a better place. So
yeah, I think everyone in the industry right now has a really, really big opportunity to introduce 3D printing as a sustainable way of manufacturing, whether it's down to things like the packaging of consumables or how the machines actually operate, because 3D printing is actually a very efficient manufacturing process. So we have this opportunity, as 3D printing will start to scale, to have these, best practices implemented kind of from the ground floor. Um, because as I'm sure everyone, like, you see the industry projections, the amount of printers out there is predicted to be 20 times higher than it is now in the next 10 years, which means that they're going to consume at least 20 times the amount of material. And it's actually more than that. Like it's probably 100 times more, since we found that even automation causes people to use at least 4 times more material per unit time than they would have before. All's that to say that if we can introduce this sustainable mindset and start making our products more sustainable now, it creates a really good foundation for the future. And it also, it introduces 3D printing not just as a new manufacturing technology, but as a sustainable manufacturing technology. And I think there's a lot of opportunity to offset a lot of the very wasteful practices that are kind of widespread right now. So I'm super happy to hear that you're adopting cardboard filament spools and better packaging. And I'm also like super into whenever filament manufacturers announce like biocompatible materials or biodegradable materials, because let's face it, 3D printing is still plastics manufacturing. So
Right.
the better materials that we can produce, and the if we can make materials that are much less harmful for the environment and introduce these as a widespread or as a standard option for people, then it's more likely that they'll use those. And I think 3D printing, just due to the nature of it, opens the door for a lot of materials that are not compatible with injection molding, but might be like really good for the environment.
Yeah, I agree, and I think this kind of goes back to what we're talking about, like getting more people involved in 3D printing. I think as more people see 3D printing, especially FDM, as a more eco-friendly source of manufacturing, coupled with better materials on the environment, I think you're going to start seeing more people transition to 3D printing as a whole.
Mm-hmm.
And I think it all starts with education too, and making sure everyone is aware and making sure everyone knows how much better 3D printing can be compared to standard manufacturing.
Yeah, I always like to consider like one. We had Thomas on a few streams ago, and he's making ring sizers at a rate of about 100,000 a year, and he's running that entire production system out of like 2 outlets in his basement. And he's able to do full scale production, 100,000 parts. There's like 24 unique parts at that, and it's running off of basement power in his house. And I think that's just a really good demonstration of how much more efficient 3D printing is, and how much less wasteful it is. Just even in terms of the space usage, you don't need special facilities for it.
No,
Takes up a wall in your basement.
Yeah, like
really. I mean, a lot of 3D printing companies are starting out in basements, with 3 to 5 printers, and they're just scaling up as they go, and they're able to do that because of cost and how easy it is on the environment.
So I think we're we're coming up to the end here, and I'd just like to thank you guys again for staying with us, and your time on such a long, but I think it's been a very fruitful and interesting discussion. I'm super excited to see more of your products, and especially the cardboard spools, but just to see new applications that your materials are able to do in industry, and you know, experimenting with the PolyCast, and now I'm gonna have to try smoothing it because I haven't done that before. But experimenting with that and experimenting with some of your other materials for production use has been really cool. And of course, any knowledge that we gain, you know, testing in-house here, will pass on to our customers as well, and pass on to other, you know, people in the 3D printing community. So yeah, thank you again so much for joining us for this stream, and it's been wonderful going over all of this and discussing kind of what lies in store for 3D printing, especially for manufacturing.
Mm-hmm.
Well, I mean, it was great meeting with you guys. It was such a pleasure being on here, getting to speak about Polymaker and this great company I work for. And so,
Yes, yeah, thank you very much for having us. And I do think we'll have more to talk about. You know, we have a large part of our customer base that begins as maker with a 3D printer, trying around, and usually business idea come, and you can very easily go from your prototyping to manufacturing by keeping the same tools, and automation help them to make that step. Yeah, thank you again for having us.
Yeah, I'm really looking forward to see kind of what new materials you guys are coming out with, and especially any sort of ways that you could use 3D printing to like supplement existing manufacturing.
Yeah,
Like I found the way that people use PolyCast for investment casting is really cool.
I know.
Just got me thinking about different ways that you could use 3D printing in tried and true like traditional methods of manufacturing. So it's been a really cool conversation, guys. Thanks.
yeah, awesome. Thank you guys so much.
Yeah, and we got one last question from chat as we're winding down. Kevin's asking if you guys are planning to use, you know, adhesive or metal in the cardboard spools to help with the recyclability. Because I know some of them have like metal fairings, I think.
So you mean whether we are going to add metals to our spools?
Yeah, like some cardboard spools. I guess he's asking about the recyclability. Some cardboard spools use metal in order to bind the spool together, and some use adhesive. So I guess he's just curious whether which
Okay.
path you guys are looking into.
Okay. So far we're using we actually developed our own glue for
Oh, cool. Okay.
for these spools. We because of the spool will go through the drying process, so and will go through a lot after arriving to the customer. So we are currently using glue for this application. Yeah.
That's awesome. Yeah,
Cool.
that makes it way easier to recycle. And there you go, Kevin.
They made their own glue.
Yeah, that's brilliant. That's awesome.
And it's recycled cardboard as well.
Yeah.
So it's
cool.
already recycled cardboard. Yeah.
Yep.
Perfect. Oh, exciting. Well, it was a pleasure talking to you guys, and as you said, I think there's still a lot more to discuss. So I guess people should stay tuned for another stream sometime in the future.
Absolutely. We'd definitely love to come back.
Yeah, it was amazing having you.
Yeah.
Thank you guys.
Yeah, and with that said, I guess everyone who's stuck around, thank you so much for watching. Make sure to join our Discord community where there's tons of people using different materials and on Quinley for actual manufacture. There's a lot to learn there, and yeah, make sure to share this video. I think anyone, it's been a pretty dense, it's been a pretty dense hour and a half, so there's a lot of knowledge in this video. I think it will be, anyone that's into 3D printing, definitely share it with them because I think they'll learn a lot. And so yeah, thank you again, and we'll go to our outro.